Securing an A-star on the IGCSE Math Paper 4 requires mastering the multi-topic problems found at the end of the exam. Let's break down a high-stakes scenario involving probability and algebra. Consider a bag with 4 red balls and an unknown number of blue balls, which we'll call x. This makes our total number of items x plus 4. We are drawing 2 balls at random without replacement. This means the contents of the bag change after the first draw, affecting the total count for the second. The problem provides a specific target. The probability that both balls drawn are blue is exactly 1/3. We will use this known value to solve for x. Instead of drawing a full cluttered tree diagram, we will map only the specific branch we need. We are looking exclusively for the blue then blue pathway. Focusing on this single path prevents us from getting lost in irrelevant data, keeping the cognitive load low while we build our algebraic model. On the first draw, the probability of picking blue is x over x plus 4. On the second draw, it's x minus 1 over x plus 3. To find the combined probability, we multiply these fractions together, setting the expression equal to 1/3. To solve this, we multiply the numerators to get x squared minus x, and expand the denominators to get x squared plus 7x plus 12. By cross-multiplying the entire equation by 3, we move our variables to one side. This initially results in 2x squared minus 10x minus 12 equals 0. By dividing the entire equation by 2, we arrive at our simplified quadratic, x squared minus 5x minus 6 equals 0. Now, take a moment to look at the equation. Try to mentally factor this quadratic before the solution appears. The equation factors into x minus 6 and x plus 1, giving us 2 potential solutions, 6 or -1. Because we are dealing with a physical count of balls in a bag, the negative root is impossible. We reject -1, proving that there are exactly 6 blue balls. Let's increase the complexity. A third ball is now drawn. We need the probability of drawing exactly 2 blue balls across all 3 attempts. There are 3 distinct ways to achieve this: blue, blue, red, blue, red, blue, or red, blue, blue. Look at the numbers for each path. In every scenario, the numerators are 6, 5, and 4, and the denominators are 10, 9, and 8. Only the order changes, which means the final product for each path is identical. Since the value for every path is the same, we don't need to add them individually. We can just calculate one path and multiply the result by 3. Executing that multiplication gives us a final probability of 1/2. Remember the 3-step method. Isolate the required path, use algebra to build your quadratic, and apply multiplication shortcuts to identical probability branches. To support that journey further, connect with Fundoo Tutor for expert one-to-one guidance tailored to your child's learning needs. Mastering these logical bridges and algebraic shortcuts is what transforms a standard exam performance into an A-star result.